Adam Rees on the cosmos and how we perceive it, excluding measurement mistakes. The possibility that we have misunderstood the universe is still real and exciting. A Nobel Prize winner warns us that the James Webb Telescope provides evidence that something strange is happening in the universe. If we believe the most recent measurements from the James Webb Telescope, our cosmos would have shifted in such an odd way that there is no explanation for it. But what would that actually mean in practical terms? Are we really helpless against the most recent developments, or do we perhaps already have a new explanation? One of the most prominent cosmologists of our time, Adam Rees, won the Nobel Prize for his groundbreaking research on the universe's expansion years ago. He also found a concerning discrepancy in the Hubble constant's measurements, which he called the Hubble tension. Rees eagerly anticipated the James Webb Telescope's inauguration alongside hundreds of other scientists worldwide. The new technology would ultimately demonstrate the universe's actual nature. Finally, responses to queries like whether Rees's measurements were inaccurate or whether the earlier readings were incorrect should bring us clarity. Naturally, it was also possible that the Hubble tension was an unexplained phenomenon at the time, but no one wanted to acknowledge that. The Webb telescope startled scientists because the most recent measurements verified the accuracy of all earlier measurements, ruling out a pure measurement error as the differences in the Hubble and Webb each made two measurements, one using sides, as standard candles and the other using type 1a supernovae. In this context, standard candles are measurement constants that scientists use to achieve exact measurement results in the universe using the absolute brightness of these phenomena, so both measurement methods should show similar results. Therefore, measurements definitely do not occur because our telescopes measure incorrectly. Minor measurement discrepancies would have indicated a difference in the absolute brightness of the standard candle and could have been explained physically, but the difference is so large that Adam Rees believes the Hubble tension is pointing us to other fundamental misconceptions about the universe. What was measured was the expansion of the universe, or more specifically, the rate at which the universe is expanding and how it is accelerating or decelerating in the process. Did you know that Adam Rees is the father of dark energy? In 2011, Rees shared the Nobel Prize in Physics with Brian Schmidt and Saul Perlmutter. The three scientists were honored for their special discovery, that the universe is not only expanding, but is doing so at an increasing rate. This realization also shocked the researchers because actually the universe should be slowing down. Imagine how the Big Bang was an initial energy, and then the universe races off forming matter and taking up an ever-increasing space according to our current physics. It should actually slow down. At some point, this idea that the universe will eventually run out of steam, so to speak, led to the big freeze theory in which the universe will end up in a kind of state of shock at some point in the distant future. When all energy is used up, all processes come to a halt, and the universe practically freezes. But the measurements taken by Rees and his colleagues showed that the expansion of the universe is not slowing down, it's accelerating. But how can that be? This counterintuitive fact led to the introduction of the concept of dark energy. This force, which no one has yet seen or measured, is thought to be responsible for the mysterious, accelerated expansion of the universe. To confirm these theories, prior to the James Webb Telescope's launch, the Hubble Space Telescope was in use. Adam Rees is employed at the Space Telescope Science Institute, which is in charge of the Hubble Space Telescope, in addition to being an astronomy professor at Johns Hopkins University. Confirmation of Rees's theory via the James Webb Telescope. Take a moment to consider how you perceive the universe. Do you also consider the universe exhibits evidence on multiple levels of an expansion of the total space it occupies? Up until now, the only logical explanation for these effects was that the universe expands from a starting point. But as was previously mentioned, the universe would eventually have to slow down, or at the very least, it shouldn't expand faster and faster. This is a concept that may seem a little crazy to us, but it is true forever. This is where the James Webb Space Telescope's special mission during its 2 years of operation comes into play. Since there hasn't been any evidence of a dark age or actual remnants of the Big Bang, NASA's newest telescope has already shown us a number of phenomena that support Rees's theory. These include clusters of galaxies that are so massive and far-reaching that they cast doubt on the idea of an isotropic universe. All this, together with the phenomenon of the Hubble tension, confirms the assumption that we simply did not understand the universe correctly. So far, these new findings will now possibly lead to fundamental changes in science. It is not only Adam Rees who sees that the scientific understanding of the world and the universe is currently facing major challenges. Throughout science, more and more researchers admit that more and more unsolved puzzles in cosmology are forcing us to rethink radical changes in the universe. Confirm it. Who would have thought that a simple telescope could cause our entire cosmology to collapse? Although the James Webb Space Telescope is not just any instrument, but the best telescope we humans have ever built. Nobody expected these observations. It's as if a completely different universe is suddenly appearing before the researchers' eyes than the one they thought they knew. There are indications that the universe is older than assumed, and that galaxies were formed faster and differently than previous theories had predicted. We may even have to get used to the idea that the universe is infinite. Perhaps we don't even come close to understanding how matter really comes into being. James Webb also provides observations that cast doubt on the existence of dark matter. If dark matter does not really exist, another pillar of the old theories will have been lost. But how can we then explain the phenomena that led to the invention of this mysterious matter? It was researchers like Edwin Hubble and Fritz Zwicky who predicted that there must be an invisible form of matter. Only with the help of this form of matter could the incoherent rotational behavior of galaxies and some other phenomena be explained. There are some other approaches to explaining these phenomena without the existence of dark matter, but they are not quite as coherent. Webb also shows us that the assumption that the universe looks the same in all directions could be flawed. This effect of uniformity is what scientists call isotropy. If this isotropy does not exist either, then the old cosmological model is shaken even further. In the early 2000s, Ree and other researchers introduced the concept of dark energy to explain the accelerated expansion of the universe. However, the existence of this form of energy is still unproven, just like the existence of dark matter. Due to these new discoveries, it's expected that the standard model of cosmology will soon be fundamentally revised. But where could this change lead us? Now these new worldviews amaze us. Imagine we live in a cosmos in which not a single physical constant is correct. That would mean that Einstein's theory of the constant speed of light is not true, that standard candles can never produce the same results, and that physics changes regionally and even over time. Within our cosmos, such considerations arose after the latest measurement. Results of the JWST and the latest theories go even further. In addition to the idea that our physics can only describe a part or an apo of the universe, there are approaches that see intelligent forces in dark matter or dark energy. This would mean that our cosmos has something like a soul or its own intelligence, which in turn could explain who created the universe in the first place, and why we would still be a long way from having real answers to our questions after such insight. But if such crazy assumptions were confirmed, we would at least know that there is such a thing as a creator intelligence. Until now, we have always looked into the light and into matter to understand the universe. But now it is becoming apparent that the structures we are looking for prevail in the mysterious darkness of the universe of all places. However, this has not really been proven either, and we will have to continue to observe what is unfolding before our eyes, what measurement results we get from the latest Webb observations, and what that means for our science. We humans have begun to explore our surroundings, and at some point the universe, because we wanted answers to the questions of who or what created it and why it exists. We may now be at a turning point that changes our old worldview so dramatically that it resembles a revolution in knowledge and science. Less daring theories merely assert that our universe is much older, or that it may not have a beginning or an end. But where do the signs of expansion originate? There are intriguing new theories that contend that regional currents govern our cosmos, visualizing it as a wafting bubble formation that contracts or expands regionally to reach varying rates of acceleration and expansion makes perfect sense if there was never a Big Bang. It is hardly surprising that there hasn't been any concrete evidence for the Big Bang either. even though for a while all the theories seem to fit together fairly well and support the idea of a starting point around 13.8 billion years ago. However, if we look more closely at quantum and particle physics, we find more evidence that something is wrong with our old worldview. From the quantum world, we know that our universe must be far more flexible and changeable than previously thought, and you might be surprised to hear that particle physics has yet to produce any concrete proof of the actual physical existence of matter. Our cosmology is based on the observation of material phenomena, and researchers have inferred forms of energy and forces from the behavior of matter. This could have been a clear error. Look forward to many new video blockbusters by subscribing now.